The nature of warfare and national defense is undergoing a profound transformation. For centuries, conflicts were primarily waged on land, at sea, and later in the air. However, the 21st century has ushered in a new, critical arena: space. Nations now recognize that control of space offers unprecedented strategic advantages. It is the ultimate high ground, providing a vantage point for surveillance, communication, and potentially the deployment of advanced weaponry. Satellites have long been used for intelligence gathering, navigation, and communication, playing a crucial role in military operations. The reliance on these space-based assets has grown exponentially. Consequently, the ability to protect these assets and to deny adversaries the use of their own has become a paramount concern for major world powers. The development of anti-satellite weapons and other space-based offensive capabilities signals a new era of strategic competition. The concept of space dominance carries immense implications for global stability. An attack on space infrastructure could cripple economies and societies worldwide. Therefore, the pursuit of defensive capabilities in space is seen by some as a necessary precaution, while others view it as a dangerous escalation. On May 20, 2025, a significant announcement captured global attention. United States President Donald Trump unveiled an ambitious new missile defense initiative named Project Golden Dome. This project aims to create a comprehensive, multi-layered shield designed to protect the United States from a wide array of advanced missile threats. The scope of these threats includes intercontinental ballistic missiles, hypersonic missiles, cruise missiles, and sophisticated systems like fractional orbital bombardment systems. The stated objective is to deter and defend against potential attacks from nations perceived as adversaries, specifically naming China, Russia, Iran, and North Korea. Leading this colossal effort is U.S. Space Force General Michael Getline. The development plan involves the seamless integration of ground-based, sea-based, and space-based components. This integrated approach leverages recent breakthroughs in satellite technology, reusable launch vehicles, and the miniaturization of powerful sensors. The primary goal of Project Golden Dome is to provide an impenetrable defense, thereby enhancing American security and reinforcing its strategic posture on the global stage. Proponents argue that such a system is essential to counter the proliferation of advanced missile technologies by potential adversaries. The technological foundation of Project Golden Dome is a complex tapestry woven from cutting-edge advancements in several key areas. At its core is an extensive network of highly sophisticated sensors. These include advanced infrared systems designed to detect the intense heat signatures produced by missile launches, and powerful radar systems capable of tracking objects with remarkable precision. These sensors will be strategically deployed across a constellation of satellites in low Earth orbit, at various ground-based stations, and on mobile sea-based platforms. A critical element of the Golden Dome's architecture is its vast satellite constellation, envisioned to consist of hundreds, or potentially even thousands, of small, interconnected satellites. Once a threat is detected and tracked, the Golden Dome will rely on a new generation of interceptors to neutralize it. The primary method of interception involves kinetic kill vehicles, non-explosive projectiles designed to destroy incoming missiles by colliding with them at extremely high speeds. The integration of these components requires an exceptionally sophisticated command and control system, likely incorporating artificial intelligence and machine learning algorithms. Project Golden Dome is conceptualized not as a single infallible barrier, but as a deeply integrated system of systems, providing multiple layers of defense. The first critical layer is detection. As soon as a hostile missile is launched, the global network of space-based infrared sensors, augmented by ground and sea-based radar systems, is designed to pick up its signature. Following detection, the system moves into the tracking and discrimination phase. Advanced algorithms, likely powered by artificial intelligence, will process the sensor data to calculate the missile's precise trajectory. This accurate tracking information is then relayed across the command and control network to the appropriate interceptor platforms. The primary interception strategy focuses on the boost phase, the short window immediately after launch when the missile is most vulnerable. Should a missile evade this initial boost phase interception, the Golden Dome's layered design provides further opportunities to engage the threat. This redundancy is key to the Golden Dome's promise of comprehensive protection. Project Golden Dome responds to the evolving global security landscape and advanced missile technologies by potential adversaries. Nations like China and Russia are developing new offensive missile systems, including hypersonic glide vehicles and fractional orbital bombardment systems. These weapons exploit gaps in U.S. missile defense capabilities. Hypersonic missiles can evade radar detection and challenge current interceptors. Golden Dome's advanced satellite-based tracking counters these threats. Protecting U.S. satellites is vital for national security. The Golden Dome project signals a U.S. commitment to high-tech solutions. The unveiling of Project Golden Dome immediately brought its staggering financial implications to the forefront of public and political discussion. President Trump provided an initial estimate of $175 billion to be spent over a remarkably short 3-year period. However, independent analyses suggest that the true cost could be significantly higher and spread over a much longer time frame. The Congressional Budget Office has projected potential costs ranging from $161 billion to an astounding $542 billion over 2 decades. Such vast expenditures inevitably raise questions about opportunity costs. The resources dedicated to this celestial shield could, critics argue, be allocated to other pressing national priorities, such as healthcare, education, infrastructure renewal, or research into other critical technologies. Despite the high costs, proponents of the Golden Dome point to several potential positive economic impacts. The project is expected to stimulate significant job creation across the aerospace, defense, and high-technology sectors. However, the sheer scale of the required funding also presents considerable economic risks. Project Golden Dome's strategic implications extend far beyond U.S. defense. It could reshape global power dynamics. A comprehensive missile shield changes nuclear deterrence, challenging mutually assured destruction. China and Russia criticize the initiative. They see it as a strategic U.S. advantage. This could spark an arms race involving countermeasures. It impacts U.S. alliances, enhancing allied security, but raises coverage questions, prioritizing U.S. homeland. Canada's role is crucial, especially in Arctic tracking. Geopolitical tensions may rise as nations reassess strategies. The debate continues on stability. Despite the ambitious vision and strategic rationale behind Project Golden Dome, its path to realization is fraught with significant controversies and formidable hurdles. One of the most immediate and persistent questions revolves around its technical feasibility. Experts in missile defense have highlighted the immense difficulty of achieving reliable boost phase interception. The sheer scale of the proposed satellite constellation, potentially numbering in the thousands, presents another set of challenges. Adversaries could develop and deploy anti-satellite weapons to degrade or destroy portions of the constellation. Cost overruns are a perennial concern for large-scale defense projects, particularly those pushing the boundaries of technology. The initial $175 billion estimate for the Golden Dome over just 3 years has already been met with skepticism. Ensuring financial sustainability and preventing the project from becoming a fiscal black hole will require stringent oversight and realistic budgeting. Finally, the project faces significant political and bureaucratic hurdles, with congressional approval required for the substantial funding needed. Project Golden Dome, as it stands on the cusp of development in mid-2025, represents more than just a new missile defense system. It embodies a pivotal moment in the evolution of strategic defense, signaling a definitive shift towards the operationalization and potential weaponization of space. Its legacy will likely be judged not only by its technical success or failure in shielding the United States, but also by its profound impact on international relations, the future of warfare, and humanity's relationship with the final frontier. The decision to pursue such a system is a clear indication that space is no longer a passive backdrop for terrestrial affairs, but an active and critical domain for national security. The initiative builds upon decades of U.S. investment and research in missile defense technologies. The critical advancements in reusable launch vehicles have made the deployment of large satellite constellations far more economically viable. Miniaturized sensors, advanced data processing, and artificial intelligence are also key enablers. However, this technological prowess does not automatically guarantee strategic wisdom or unqualified success. Critics argue that an over-reliance on complex, space-based defenses might prove less efficient or reliable than robust regional defense systems, combined with strong diplomatic efforts and arms control treaties. Ultimately, the Golden Dome project forces a global conversation about the rules of engagement in space and the future of strategic stability.